Hello students, in this video we'll study about the next topics in motion in one dimension, and those are graphs. In graphs we'll be studying about position time graph and velocity time graph. Let's look at the situation given here. There are two figures given. One on the left, it shows a motion diagram where the diagram is represented that a body starts at times t equal to 0, then goes to a distance of 2 meters, and then again turns back and goes to a distance to a final position of -2 meters. Now the same data is shown in a graphical manner. Now here you can, on the graph you can clearly see that at t equal to 0 position is x equal to 2 meters, and at t equal to 8 the position is x equal to -2 meters. So this comparison clearly shows that a graphical representation is more easy to understand, and hence it can be easily interpreted. The data can be easily interpreted and analysis becomes very easy for us. So in physics, we'll look at position time graph and velocity time graph in this particular topic. So what is the position time graph? Position time graph generally along x-axis, along the vertical axis, what we do is we take position. So we consider this to be y-axis, and on the horizontal axis, that is the independent axis, we have time. Now we have tried to represent whatever is the position given in this motion diagram. You can see that at t equal to 0, the object is at position 0. And somewhere here, you can see that as it goes up till t equal to, each frame is 1 minute. So at t equal to 2 minutes, it's slightly over 100 meters. T equal to 4 minutes, let's say it's slightly less than 200 meters. So all these points that are shown here, we are trying to plot it on the graph, and we got a graph something of this kind. Now because this is a plot between position and time, we call it as position time graph. Now there are various things that we can see from here. So let's try to analyze that properly. So if I try to take some general graphs of position time or general, let's say, situations. If a body is at rest, the position time graph is shown this way. You can see that the position time graph is a straight line parallel to time axis. Now why is it a straight line? It is straight line because the position remains constant. So if a body is at rest, it means position remains constant. So initially, let's say it is at a distance of 10 meters from the point of reference. It continues to be at that distance throughout the time. Then we have the graph of a body which is going with constant positive velocity. Now slope of a position time graph shows, or slope of a position time graph gives velocity. Here you can see that the slope is positive. Because the slope is positive, the velocity is positive. Hence I'll just let's say we take it as theta. So if I want to find velocity from here, I can directly write v equal to tan theta. Now here you can see that the slope is positive, so velocity is also positive. Now if a graph is shown something like this, here you can see that theta is this one and it is going down. So that means what is it? Slope is negative. Because the slope is negative, this is a situation where the velocity of the object is negative and constant. Now let's see how do we represent a situation where velocity is increasing or decreasing, that is acceleration is positive or negative. In the first case, you can see that the slope is increasing. Now how do I find slope? If I draw something like this, slopes like this, I see that slope is increasing. If slope is increasing, what does it mean? Velocity is increasing. So the first graph is a situation of constant positive acceleration. Similarly, in this case, you can see that the slope, as we go along, as we go forward in time, the slope is decreasing. So because the slope is decreasing, this is constant negative acceleration. So in general, if I have a curve upwards like this, I can say that acceleration is positive. And if I have a curve negative like this, downwards like this, I can say that acceleration is negative. So in a position time graph, an upward concave curve implies positive acceleration, and a downward concave curve implies negative acceleration. Now let's go further. So here let's try to analyze what we have understood. In the first graph, I can see from O to A, there is a constant slope. So I can say that this part, what is it? It is constant positive velocity. So I'll write it here. This part is OA is what? Constant positive velocity. Similarly, you'll see that there are different parts. AB is again a straight line. AB is also, if you see, it is straightly up, so it is positive velocity. BC negative velocity, and CS is again negative velocity because it is downwards. So this whole situation is a situation where the velocity of the body is decreasing. So I can say this implies a body moving with decreasing velocity. And if I want to look at initial condition, so what can we say about initial condition? Initial slope is positive, so I can say initial velocity is positive. Now let's come to the next one. Here you can see that if I draw a graph slope like this, it is downwards. Again, slope is slightly increasing and slope is increasing. So this is a situation where initial velocity is negative, and because you see that slope is gradually increasing, acceleration is positive. So this situation gives me this graph gives me a situation where initial velocity of the object is negative and acceleration of the object is positive. So this is about position time graph. Now let's look at velocity time graph. So what is velocity time graph? Here you can see that the same thing. I tried to graph whatever we have already done before. The dots represent the position at different times, and the slope represents the velocity. So for this part, some velocity is there, this part some other velocity is there, this part some velocity is there, and we know that average velocity is delta x by t. So I can say that from here to here the velocity from here to here there is one velocity, and then velocity decreases, and then velocity increases. Now the same thing. So if I want to find velocity from the position time graph, how do I find velocity? I can find the slope. You can see that there is a slope here, delta x and delta t. So v equal to delta x by delta t. So in this particular case, the velocity would be 300 meters per 3 minutes, or I can say velocity equal to 300 by 3 meter per minute. That is equal to how much? 100 meter per minute. This is what is velocity. Now the situation that we have seen, let's try to draw a velocity time graph for the same situation that we have been seeing. So from here to here, what is happening? The velocity is constant. So I want to find what is velocity. Roughly we can see some velocity, and similarly from here to here there is a lower constant velocity. Again there is a higher constant velocity. So the first part I see there is a velocity which is given like this. Similarly second part, what we have? A velocity which is slightly lower, and the third part again velocity which is higher than this. So these two graphs show the same situation, but the first one shows position time graph and the second one shows velocity time graph. Now let's look at how do we represent the common situations that we have, that is body at rest, body moving with constant velocity, all those things. So the first graph represents constant positive velocity. Because the graph is parallel to the time, it means velocity remains constant. And if I want to represent constant negative velocity, I'll just draw a line below this, that is on the negative part. So that becomes constant negative velocity. And slope of velocity time graph gives acceleration. So if I take this as theta, you see that slope is positive, so tan theta would be acceleration. As slope is positive, acceleration is greater than 0. In this case, you can see that the slope is negative, so I can say acceleration is less than 0. Now again you can see that if slope increases, acceleration increases. So the first graph shows increasing acceleration, and as slope decreases, acceleration decreases. So the second graph shows decreasing acceleration. So the two things that we have to remember in case of velocity time graph is slope of a velocity time graph at any point gives acceleration at that point, and the next thing is area under velocity time graph always gives us displacement. Now let's look at a small example. Now figure shows the displacement time graph of a body. What is the ratio of the speed in the first second and that in the next 2 seconds? So in the first second, what is speed? Now speed is distance change in position by time. So 30 minus 0. So final position minus initial position is how much? 30 minus 0 by time taken is 1 second. So this is, I'll say, speed or velocity in 1 second. I'll call it as v at t equal to 1 second. So how much is that? 30 by 1, that is equal to 30 meter per second. Now because they're asking about speed, I don't have to bother about direction. So for the second part, what is initial velocity? Initial position is 30, final position is 0, and the time taken is 2 seconds. So I'll say v2 equal to how much? 0 minus 30 by 2. That would be equal to minus 15 meter per second. But because we are talking about speed, I'll say speed is only the positive part, the magnitude, that is 15 meter per second. Now what is the ratio of the speed in the first second? So I can say v1 by v2 equal to 30 by 15. That is equal to how much? 2. The ratio of the speed in the first second and second is 2. Now let's look at another example. What does it say? Given this position versus time graph, what is corresponding velocity versus time graph? Now here you can see that from this point to this point, what we can say, position is constant. So position constant means what can you say about velocity? Velocity equal to 0. Now from here to here, position is decreasing or the slope is negative. This part, what we can say, velocity is negative and constant. So let's look at the graph which depicts the same thing. So first part, velocity should be 0. So this is 0 and this is 0. This graph, the first part is right, this part is right. Now second part, velocity should be constant and negative. So this is right. So the right answer is this graph. This would be the right answer. So this is about position time graph and velocity time graph. I hope you could follow what is done.